Okay, so I'm just giving you a look at the units themselves now that you've seen the overview of the system. This is the base unit, and you can see on the left here the Ethernet cable going out to my router. On the right I have it powered at the moment just through, this is the programming lead, and it's an FTDI cable. And you can see that I have an RF unit. The blue rectangle there is my RF unit on top. It's a 433 megahertz RF module. So that's the base unit. Receives a signal from the power meter, relays it back through Ethernet right now. There's another version of it available that I'm building next, and as you can see, it's got a memory card on the bottom right there that I can save data to. This new unit is an 800 megahertz, 868 megahertz device. So that's the base unit, and then this is the power. This is the power meter. I just disconnected it for convenience, and that's the inside of it. You can see here you've got your 9 volt AC reference, pulse and temperature inputs, 3 CT inputs, as you saw in the introductory overview. Alright, thank you. So this is the water meter. It's Elster water meter, and you can see the reed attachment, and it's being fed back to the transmitter, which is has the pulse input on the right, and it's configurable in terms of the frequency of signal that it sends back to the base unit. It's powered on the left here by a 5 volt mini USB. You can see it flashing away there, but it can also, I left it open for convenience, it can also be powered by two batteries, two 1.5 volt batteries. So that's it. That's the power, or the pulse transmitter. I'm using it for water here. This is the gas meter, and this unit here is the INZ61, which is just a pulse unit that works with the BKG4 meter, and it sends a pulse output up to my power transmitter, which is powered through 5 volt USB, mini USB, but can also be powered through battery. I also have a 9 volt AC reference voltage, so I can calculate power factor, and this is my pulse input from the gas meter. And then I also have a CT clamp input for the electricity meter. In this through here I can have up to 3 CT inputs, 1 pulse input and 1 temperature input. I'm just including the 9 volt reference. For most domestic installations it isn't necessary if it's near unity power factor, but it is an option. But obviously it complicates installation because you need a 9 volt AC to AC step down so that you get it into the transmitter. Same as the water transmitter, it's configurable in terms of how frequently you transmit data to the base unit. Okay, this is the energy visualization part of the project. I'm going to walk you through it, so I'll just log you in. And once you're logged in, the user is taken immediately to the dashboard, and here you'll see this is installed in my own home, obviously. My water usage over time, my electrical power usage over time, and energy in kilowatt hours, and also my gas. You can stack bar charts together showing, for example, solar energy generated on site or wind in the same display as the energy taken from the grid, but this is just a basic proof of concept display as to what's available. So the inputs, there's a selection of inputs that you measure, and based on these inputs you can create feeds. So you can measure watts, for example, and power factor. You'll see that we have power factor there as well. So you can measure watts and then from that generate kilowatt hour information, etc. So I've just switched on my oil-filled radiator here, so you can see we have an instantaneous view as well. The cost information then is displayed on each of the energy bars with a projection for the year. So this can be quite useful in projecting trends or looking at problem areas. Thank you.